Hey, John here. Here's the state of play with the Revision 0 circuit board that we use for testing the VDP chip here, the VDP interface for the Z80 Retro board, okay? This is Rev 0, complete with the power bodges and missing bypass cap. Yeah, okay, forget this. Garbage. This was greeting me as I arrived home today. Much to my surprise, this is like 3 business days sooner than they estimated, which I thought was a little long when they first sent the shipping information, but I did not expect it to go nearly this fast. Anyway, this should be revision 1. Let's see what we got here. Now, last time, they gave me more circuit boards than I ordered, and it might be that they did it again. 1, 2, 3, 4, 5. There's 6 in here. So who knows? Maybe they love me. I don't know. Sometimes that actually does happen. I think probably what happens is they have something when they run it and they have to run another board because they don't make these tiny things. They make these giant panels. And maybe they needed to make 6 giant panels. I happen to be part of, off in the corner, a wasted part of the run when they make this fiberglass and they make these boards. And maybe they figured, they'll do an analysis and optimize their costs and figure it's better to just give me the 6th one rather than throw it away because it becomes waste, right? This is, e-waste, so they don't have to throw it away if they ship it back to me. And in theory, I'm happy because I got more than I paid for, which is, in a way, that's cool. If it works. Hopefully, this one will work. Well, let's have a look inside here. Anyway, I'm just saying, and that's not just JLC PCB. This has happened to me, even at like PCB Way and other stuff like that. I think this is a common thing for a lot of these board houses to do when they run into a situation. Go ahead and throw us a favor. And it's nice when that happens. So here it is, nice and upside down. Get the bypass in there. This has been moved down. And, I just kind of really hope that when I move things around, I didn't screw it up. So while I'm sure the power's right this time, when I move things around, I could have broken something else. That would be really upsetting. And that's the kind of thing that can happen. This was a bit of a risky move over here. Literally, no pun intended. But we've got these parts, remove the ones we don't need and rearrange things to clean up the video output circuit. And by now we know the drill. Let's put the parts down in order of increasing cost. Right? So if the board doesn't work, we're going to minimize the cost of this failure. So I'm going to put down, we also need to do this in a kind of an order where, for example, I'm going to have to solder in, remember, this long pin header. If you have a short pin header, it'll be a lot easier. I don't have any 40 pin, short pin, female headers. These cost me about $1.25, and there's a link to where you can get some of your own on the GitHub repo for the Retro VDP board interface. That'll be in the description below this video, okay? So I'm going to start with these 0.1 microfarad surface mounts because they're a lot cheaper than the through holes. Maybe the final draft I'll make it look nice and use all the through hole parts and stuff. I don't have a lot of spares. I've got thousands of these in stock, and these are less than a penny each. So these are the ones I use for screwing around. Now we're doing surface mount soldering, so I'm going to go ahead and put a paper blotter in here because this is a nice silicone mat. I did it directly on the mat last time. I had to clean up all the flux. It's much easier to just cut a flap off a DigiKey shipping box and throw it away when it gets all covered with sticky flux. These are 0603. These might be easier if they were 0805s, but I don't have any 0805s. All right. For some reason, 0805s cost a bit more than the 0603s, probably due to demand, no volume and therefore the price goes up. I know that's true with resistors. They're a totally different ballpark in terms of cost. 805 resistors are so wonderfully easy to work with on surface mount. But, honestly, they're just too darn big. They're just too dang gangly. All right, so I did one end of each one of these capacitors, and normally I don't like to do it this way because in the past I have forgotten to do the other side. When you go back and finish them, that can happen, right? But it actually is kind of easier to do it this way because you can just keep dang 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 and go around the horn and do them all. And since these are the very first parts I put on here, it is easy to keep track of which ones are done. You just work from one end of the board to the other. It's at this point you can take some hot air if you really want to and reheat the whole board or put it on a solder plate, a hot plate, and reflow it and get it all perfect, if you really want it to look perfect. And I oftentimes will do that if the whole board is surface mount. I find it hard to believe I actually missed that one. I thought I counted out the right number when I pulled them off the strip and everything. I wonder if I lost one. I'll have to go back and review this video when I edit it to see if I flung it on the floor. Okay. Now, it's got sticky flux all over it, so I'm going to take some isopropyl and clean it up before I do anything else. And the reason you want to do this is because it's real easy to wipe it off like this. Just wipe across the board when all you have on there are surface mount parts, especially on the back. Once you have those sockets in there and 8 billion pins are sticking through, all you can really do is shred the napkins that you're using to wipe the board off. And I used a regular napkin here, and it's shredding all over the place. That's why you really want to use these. If I reach back in the side there, these are designed so that they don't shred like a regular napkin does. They, when they deteriorate in a way that the material doesn't clump up and get into all over the place and stick in little bally things everywhere. So you can get Kimmy wipes and Kim wipes on Amazon if you want them. From Kimberly Clark. Hey, any sponsor, hey, send me money, okay? Selling your stuff here. Okay. What do we got? Did I miss any? 1, 2, 3, 4, 5, 6, 7, 8. That's what I thought I pulled off the reel. All right. Quite often I'll use a handle or something like on a pliers to keep this thing flat and level, because if it's like this and you're up on an angle, this thing can kind of go like that and go in there screwy, and if it's flat like this, it tends to sit better on there. Now tip it up when you do these things and give it a good side look, because some of these, like this one here, doesn't look to me like it's in there very good. Sometimes you can get a big ball of solder on the pin, but it's not like a cone that goes down on the annular ring on the circuit board. That actually overall doesn't look too bad. There's probably too much solder on it, but it's probably okay. Well, of course, I've been building stuff for decades, and I wouldn't expect there to be a serious problem. You get used to knowing what's right and wrong. This doesn't look beautiful to me. A lot of the problems is all the flux everywhere, which you can wipe off and toothbrush out if you really want to. But I expect this thing to work fine as it is. So I'm going to go ahead and sneak in J6 while we're here, because that was a tight squeeze last time, and I got to get the iron in right in there and not want to melt this. And I'm going to try it and see if it's easier to do it first this time instead of last. Now, these headers are more expensive when they're gold plated, or sometimes it's just gold flash, which is not even plating. It's super cheap crap, but it's still got gold on it. And the reason you want gold, there's two reasons actually. One is because the gold will never oxidize, so you don't have to worry about it getting all messed up over the course of time, tarnishing or anything like that. And the other reason is because it's smoother on the surface of the pins somehow. I don't know if the gold fills in, imperfections or something, or if it's just they have to make the pin better before they put the gold on it or something like that. I don't know. But the gold-plated pins, when you put a shunt on there or a connector, like if you put a 40-pin connector on this, and these are not gold-plated, there's so much friction sometimes in there that you can never get it on or back off again if you ever do that. The gold ones are super smooth and they slide in and out much more reasonably, in my opinion. So my little 2-pin header pins are much shorter, as you can see if I get the right angle there, than the pin sticking out of this thing. So I'm having a hard time trying to figure out how I'm going to hold this while I'm soldering it on the other side. I could stick my hand down here, but I'd burn my finger. That's not going to be comfortable. So maybe I can wad up a napkin like this and hold it this way so I don't burn my finger. If you do this, you want to only do one pin because it could be crooked and you want to straighten it out before you do the other pin, especially if there's many pins involved. And a connector, you'll never get it straightened out if you solder in more than like 2. Because you have to heat up, you'll have to melt the solder on every single pin all at the same time in order to move it. And as you can see, it's a little bit crooked. And, we don't want that kind of low class in here. So I'm going to hold the pin that does not have the heated iron on it and just go by braille and kind of straighten it up a little bit. Oh, look at that. Oh, that's perfect. That's beautiful. Now I'll hit the other pin. All right. Now we don't know if this is going to work just yet, but a 2-pin header, that's pretty cheap. And that's all right. I'm bummed that we got to do these 40s, but oh well. And all these sockets, too, are not exactly cheap. And again, they're hard to get out if you want to try and recycle them. You can do it if you put it on a hot plate, but this doesn't work on a hot plate either because this connector here is in the way. This is difficult to recycle if you're that cheap and want to go about doing so. Usually I don't do it because I'm cheap. I do it because I'm out of parts and I don't have enough for a project and I want to steal it off another board because I don't want to wait for shipping. That's when I get aggressive about recycling cheap junk, okay? But as a normal rule, I try not to do so. Like, for example, this crystal and these capacitors, I only have 2 of these. And if I destroy one, I'm not going to wait, a couple of days and pay $10 shipping just to get one replacement part. I don't want to do that. I use the pliers to hold this socket so it's shimming it like that to hold it up against the board. Otherwise, it's free in the air, right? Sometimes you can use just a piece of tape to hold it on or whatever. Same game I always do. Start with kitty corner pins and make sure it's seated where you want it to be before you do the other 38 pins, and then get upset that it's not sitting on the board correctly. Been there more than once. Don't do it. Aha, so there you go. I got a crooked one. That's exactly what I'm talking about. Do not get lazy. Only got 2 pins. You can get it to seat back down. That's exactly what I'm talking about. Gotta feel my way down through there. Make sure the other end looks good too. Looking good. Okay. So for those of you that are still learning how to solder and having some trouble, what I'm doing here as I go, by the way, is I don't want to put the iron against the pin in the board and heat it up. I don't want to bring the iron back to the side like this. And the reason I don't want to do that is because when I'm pushing in, the pin is being pressed over one side in the hole. All right. If I release the iron to the right, what happens is the pin flexes back to the right, and it can move the solder around in the hole and cause a problem. So what I'm doing is I go in here and I kind of go to the right, and then I go up, and I'm pulling then the solder up, wicking it up the pin. So if there's too much on there, it builds a taller cone rather than smears it all over the board. And as best as I can tell, it also prevents me from bending the pin back and forth and causing the solder to do weird things and the joint to fail otherwise, because you don't want the part to be under pressure and being held under pressure by the solder, you know. Again, I sometimes rock the iron back and forth to exaggerate it a little bit here to make sure that I'm making good mechanical contact with the copper and the pin. Because a lot of times, that one does not enough heat there. A lot of times the heat won't get on the copper or the pin otherwise, and then it doesn't solder quite often. Sometimes it'll like ball up on the pin and it won't go on the copper, or it'll all go on the copper and none will go on the pin, that sort of thing. If you're having that happen when you're soldering, what you want to do is kind of rock the iron around a little bit. This pin here, these ones look weird to me, but actually that's kind of lighting artifact. I think. Get the old magno glass out. See, they look pretty good from here. The reason they simply look different, and that's what makes them stand out. There's less solder on them, but still more than enough. But I'm bothered by the lack of consistency, right? So I'm going to go ahead and throw a little more on them anyway. It could also be cold joints. While I'm talking, I'm not always doing a good job. But one of the problems with soldering like this is I'm soldering, the distance where I'm sitting is far away, and I got a weird angle on my back so that the camera can see, blah, 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 blah. Excuses, I suck. No, it's this. I wouldn't do surface mount like this. I have to remount my camera so I can get a better angle here. There's like a light right here, by the way, and what I need is it for to be on the other. Now my hand is in the way. But lighting is really important when soldering, and it's also really important on the camera. The camera really, really wreaks havoc with my ability to get good lighting here. Okay, that looks pretty good. Trying to solve too many problems at once here. And doing a mediocre job at all of them. Isn't that always the case, right? Kind of going for gold here. I probably should have put in the VDP and seen if the video comes out okay and so on. I'm assuming I did less damage than I did last time, and risking putting in all the sockets here before I start testing the video. All right, well, at this point, we can start moving over the crystal and the load caps and maybe tap some video off and see if the sanity is working and if the DRAMs blow up in my face again like they did last time. All right, here we go. Let's pull the crystal off. These should be pretty easy to redo. I only have 2 pins. They're kind of far apart. Optimally, you want them both melted at once. So what I'm going to do is kind of walk it out. I'll melt one of them and pull on the part. As you can see, I bent it one way, so it's kind of pulling on that pin. Then I'm going to melt the other one off and kind of gently push it the other way, and then it'll pull this pin through. And it's not going to happen all at once. I'll have to make 2 passes. Come on, I won't. Come on, heat it up. My iron cord is hung up on everything on the bench. There it goes. Okay, see, I pushed it the other way, then come back this way. It would have been easier to just buy a bunch of extra crystals, but I don't remember what these things cost. They might have been like $1 or something. $1 to me is just too much for a part to be wasted. And inflation, everything's going nuts. I don't really like to waste all these parts. All right, as it is, we can tap the video directly off the VDP like I did last time without any of the other chips. Just put these jobbies in there, power it on, and see if it works. Now, we know these DRAMs actually function. They may not be operating in their prime after being hooked up backwards, but we know they work. Certainly good enough for this situation. So I'm going to pry all these parts out. And I'm going to pull the DRAMs, and I'm going to straighten out their pins. And this 138 from 1979, I don't know how many of my projects I've recycled this chip into. That's legacy. John's Basement legacy right there. I should probably leave this, because I do have extra DRAMs. I have another 3 extra ones here. What else am I going to do with these things anyway, right? Okay, so we don't have the big bulk capacitor or the other capacitor on the video amp or the amp itself. So the video is going to be choppy. We've seen this before. We understand it. We expect it. We know it. So before I waste any more parts, let's fire it up. Let's see what it looks like. The now known as the trusty short circuit protected power supply, so that if it draws too much current, we don't have a fire of chips exploding in my face. Always a nice plan. I like it when a plan comes together, right? Which one of these pins is the video output, right? It's this trace, you can see if I get the lighting right, that comes in on an angle from the chip here and should reach into that middle pin there, should be the base if we look closely. Yeah, okay, so I'm going to go ahead and plug this together. Power is off. Slap it in there, and oopsie, forgot to recycle this dingus. So let's go ahead and transfer that while we're here. I mean, I don't have to, but you know, the first thing that's going to happen, it'll tip over and short out, and then I'll be peeved off. All right, don't be too lazy about these things. Actually, I should put these DRAMs back in, you know, for display purposes. Yeah, I'll do it later. Oops. There's another reason to keep the DRAMs connected to getting hung up on the Allen wrench here. This screw has a lot of friction on here. It's almost too much to grab. There we go. It's starting to come off. It's probably just the right amount of friction in there. And this is PETG. If you printed this with polystyrene, you know, HIPS, it would fracture and fall apart and grind up very easily every time you put the screw in and take it out. But PETG is a more rubbery kind of material, and it will take more beating and on and again, off again, and reuse and threading in, threading out kind of a thing before it grinds off so much plastic that it becomes worn out and destroyed. By the way. All right, again, it's lined up, looks good. Check everything. Is the one time you're lazy and cocky, that's the end of it. By that I mean the pins are not lined up when you're not paying attention, because you're yakking on your YouTube channel or some other foolish thing. So, what are we doing here? We're going to hook this up, power it on, see if the LEDs come on. And I'm going to take my video capture device. And I'm going to just throw some gator clips on here. This is terrible. You need shielded wiring and 75 ohm impedance cables and so. These aren't too long, and we know it's going to be noisy anyway, so I'm going to just do a move like that and call it even. And then I'm going to poke some wires in here and clip these on the appropriate places at that time. But let's first do a power-up test, smoke test on this thing. What did I forget? I'm talking, I'm YouTubing. Like, probably like the VDP's in backwards or something. Wouldn't be surprised. Things like that have happened, right? Okay, so the goal now is to see these LEDs come on when the power goes in, please. Yay, they came on. Now, be careful when touching for detecting problems. Do not just grind on there because you can get it really hot, really fast, and and in conclusion, really painful. Or so I've heard. Now, this is a real easy ground to pick off right there. It's like I meant to do that. Here's my favorite little jumper wire. So I can put this in this hole here where we know the video's coming out. Now remember, there's no terminating resistors. Ooh, don't just start connecting it to random things. You could wreck everything. For all I know, I already did. Okay, now we're hooked up. Let's see what it looks like. All right, so far so good. That's a good sign. Let's just go for the gold and run the green program and look at the video capture, and it ain't working. So, time to clip the scope on the video and see what's going on. Looks like it's going, but that's not the right sync. Let's add the 470 ohm resistor and see if we can get it to look a little bit better. I'm not sold yet. Maybe there's a bad solder joint somewhere. All right, disconnect the video stuff, power down. Let's put in a 470 ohm here, and then because the resistor is still too big, I'm still waiting on my DigiKey order. This thing got shipped too quick. Let's put the resistor on. Heat check seems okay. Put this on sticking up like this, so this loop will be the video that comes out of the VDP, so I'll have a nice thing to clip on with the scope. You know, I'm going to take a really close look at all the pins under high magnification here, because some of these still look wonky. Let's get some close-up view. Yeah, one of the pins, two of the pins doesn't look so good. And I will confess that it's some of the pins right in this row. I was looking at the ones over here when I was saying that I thought it was looking good. And it still looks good over where I was just pointing last. But yeah, the left side over here, there's a couple of bad pins. And they even show up a little bit here. That one there looking pretty lame. And there's another one up in here that didn't look so good. Yeah, this one here really looking kind of dry. So let me tune those up a little. Now this pin here under high magnification doesn't look too good either. In fact, it looks to me like someone soldered it and did a side-to-side motion and was letting the pin bend while the solder was cooling. So I was probably talking and not paying attention and did exactly that. Geez, this is a real problem when you're talking. This pin here, I didn't even have any solder on it. That might have been the real problem right there. Pin 1 on the VDP had no solder on it. All right, let's try again. good. My happy ground. Place there. Now, because I have this termination resistor in here, I can just clip this on for the video out. And of course, the output impedance now is much lower than it was when it was just 75. Now it's about, what, 50 ohms or something? Pretty low impedance coming out of the chip there. But I suspect this will still be okay. I mean, we did this before on the breadboard. It should generate something. It should be recognizable. Okay, everything looks hunky-dory. No one's shorting anything out. You know, that probe is in. Okay, we're good. Plug it in. Smoke test. LEDs look good. Okay, in this condition, let's fire it up and run the white program to see if we get the right signal. And we do. So that's looking pretty good. Here's what the scope looks like right now. And you can see all sorts of noise because we don't have any of the filter capacitors installed in our design. I also don't know if the DRAMs are working. Let's run, I don't care about the video noise right now. Let's go ahead and run another program that has some patterns and stuff on the screens. We can see if the DRAMs are working. Green, ooh, look at all that noise. Again, no filter caps anywhere on the power line. No, the big ones anyway. We got to put those on. But what we should be able to do is run like the mode 1. Awesome. I don't remember what mode 1 and mode 1A did versus mode 1A. I don't think I've shown this one before. We'll look at this code in a minute. This is supposed to generate this hash pattern. I download some patterns and I define some characters and things like that. We'll have to look more closely at the manual and start writing real programs. So this is actually a real program that it's supposed to look this way. It's working, and that means the DRAM is working. This is fantastic. So let's go ahead and be, methodical here. I jumped ahead too fast. I didn't remember what that was. And rerun the DRAM.com program. As you recall from last time, this outputs 112233 into some DRAM locations and then tries to read it back. So if we run and trace it until we get to, say, 130, which is what is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 22 instructions or so. Trace 22. I don't know if that's in hex or in decimal. It looks like it might be in hex. What are we doing here? We move out the 1, 2, 3, 3, then we set up the address that we want to read back from. And every time we do an in80, it reads the bytes back. So the first one is 00, and then we do another one, and we get the 112233 coming back at us. Perfect. And all these AA values are in the DRAM. One could argue it's because it's garbage, but it's not really garbage because these AA values are the character codes I downloaded to create this pattern here. And by putting 112233 in there, it may have disrupted this upper left corner. Let's run both of these programs once more and see what happens. What was that, like mode 1A or something? That was this one? And let's watch this upper left corner to see if the color changes in any way. No, it did not. I don't remember what's at the very beginning of the RAM. We'll play around with this some more later. The bottom of the barrel here, the news is this part of the circuit works. This did not work last time. It does work this time. It's fantastic. So now we can go ahead and finish up and put the filter caps in there and all the other stuff and move on. Oh, so happy. I think we got a board here that we can actually play with. If people want to build these, we probably can. Even if they're not perfect, this should be good enough to do some software development and hacking on now. This is awesome. Okay, checking for heat. These parts are a little warm. But people say these VDPs run a little toasty. Back in the day, that wasn't that uncommon. Meanwhile, I'm running low on these 470 microfarad caps. I'm going to be wasting so many of these. I must have been using them in projects over the years. Because I just bought, like, bulk. Probably like 50 of these or something. In all reality, I've had this little box of these capacitors for at least a decade. So, probably a good buy. Not too bad. Probably won't run out in the next day or two. So it occurs to me that it's possible that the bad soldering down there might have been due to me using a smaller gauge solder. I mean, my entire life, I never used solder any smaller than this. So my technique might require me, when doing through-hole, to use this bigger sized solder. Maybe that's my problem. I just misjudged. And the reason I used the smaller gauge is because it was just sticking out of my spool. It was handy. That's the story, and I'm sticking to it. I'll also say that looks like a much better joint. Therefore, in all cases, therefore, that must be what happened. Right. Okay, what are we doing here? C9, I believe that's 10 microfarads. A lot of the 10 microfarads, and these markings, 2011, I was wrong. These are 11 years ago I bought these. So this is, it's nice. You don't have to always keep running out to buy one little darn part. But, actually these wear out, right? Electrolytics don't last forever. So they might actually be more like 9.5 microfarads by now. All right, so somebody suggested on the YouTubes that I don't use a 4401, which is an inferior transistor. The quality is not as good as, say, a 2222 or possibly even a 3904. However, I want to do apples to apples. So I'm going to put a 4401 in here, but I'm not going to put it in there deep in fancy like this one, right, in a final position. I'm going to let it stick up like these guys so I can get in there. If I wanted to, I could take the cutters and cut it off, because I could then take the solder out and take the pins out more easily. Let's go ahead and put this bad boy in there. Now this is set up to have straight pins. They're not bent to match the footprint, so I'll fix that problem. Well, again, I said I'm going to let that thing stick up pretty far. It's not far enough. It's actually coming through. Can I put this on? Maybe 2 pliers will have. This is a 2 pliers shim job here. Here we go. Now, when I was a kid, in high school shop class, we were nuts about making sure we had heat sinks on these transistors when we would solder them in. I wonder if they changed the way they're manufactured so that you can use them in reflow soldering, because I don't really do that anymore. And I've never known a transistor to go bad, or that I could ever blame on soldering. I burned them up and put them in the wrong way, but never had that happen. Of course, now is the time, right? Because I brought it up. Way to jinx it, moron. Now, this won't work. Out the connector here yet, because I still got to put the ferrite bead in. Otherwise, there's no power that goes into the amplifier circuit. The 33 ohm over there is in series with this jack over there. So I won't get video over here if I don't put in the 33. And remember, C11 is the 380 to 420 or 470 puff capacitor to filter out the RF noise from the composite video coming out this jack. Now, I don't have a tiny little cap that fits in there because I got the board so fast. The DigiKey part order hasn't shown up with the new capacitors on it. So I may hack that for now. You can always replace it, pull it out and replace it later. I do have a whole bunch of these Giganto 470 caps here, and plenty of these giant 33 ohm jobbies. I would love to replace with the real ones. So this actually, I could remove these, clean it up, and make this look nice. Of course, I got the through holes, and darn it, I'd have to take the caps out. I mean, if I want true on, full on retro look. So this is still not, I don't think this will be my final draft. But it'll be fine. This is, version 2. But to get the correct, ambiance with all the through-hole parts looking like through-hole parts, I'll have to make another one. No big deal. Other than the fact that I got to pay another $1.25 for this thing over here. Maybe I can remove the surface mount jobbies. I probably can. Now I'll make them stand up opposing each other because they're all too big, but they'll kind of stay out of each other's way if you do it like this. So if you're going to do it wrong, at least pick a way where it can be wrong, but not fail. Okay? Well, it's as ugly as the other parts that are too big. It's thematically correct. And ladies and gentlemen, we're one ferrite bead away from our next test. And of course, this one's gigantic. I've got a new one that I'm ordering on DigiKey. As you can see, this thing is huge. The amperage rating on this is colossal compared to what we actually need. So I'm going to stand it up like these other parts, hoping there'll be enough room for it. And of course that is. And that actually, that's not unlike what a lot of boards looked like back in the day. To save room, you'd stand up your parts, and this is, am I right? Yes. Some boards look like that. This one looks a little messier because I'm just kind of sticking them in there. Problem, of course, with sticking these things up on commercial product is that vibration can cause these to wiggle around. It's, all these things sticking up like that. If you ship this and it's bouncing around, it wobbles back and forth, and eventually they'll break off. So that of course, is the downside of having things stick up on these circuit boards. When they're down low, there's no leverage. Or if you ground or glue this to the board, or you put some solder on there and you solder the metal case onto the ground, which is a very common thing to do with the cases on these crystals, for grounding and shielding and all that. But it'll also hold it still, so when it shakes, it can't wobble back and forth and eventually break off. So let's not do any serious long-distance shipping using dune buggies to ship these VDP prototypes around, because, we wouldn't want them to vibrate themselves to death. Not my little baby. Oh, all that, and I don't put a freaking connector on there. Well, you know what? I don't really need one, because I can still pick off the video. Now the video comes out of R3. The video is right there. Okay. Yeah, that looks good. The right side of R3 here is what runs up and around to the video output up there. Okay. So let's power it up. good sign. No, we have the filter caps in there, so we should see a clean white signal, clean green signal. Well, you know, I do have some vertical lines, a little more than before. We'll have to look more closely at that later on and rethink if we want to do any modifications to our overall filtering on our PC board. Mode 1, Mode 1A. Oops, I can't type. And there's my pattern that I created. Same as before. If we make it really giganto and zoom in, obviously the quality is vastly superior. Still see some rolling, waving things happening here, and this is very common. That's not necessarily caused by power supply noise and ripple. This is probably caused by the color burst signal phase changing and doing it too quickly for the video capture device to properly decode what color it's supposed to be at all times, and having it not quite get it right. So you end up with this weird almost flaming patterns, and then other times it doesn't do it at all, depending on which colors are next to each other. If you put a saturated red next to a saturated green and a saturated blue, the phase change of the color burst is enormous, and you can see that's having a little trouble with it here. And this up there is just terrible. But this one's not too bad. That's not too bad. This is the bane of composite video, and or the bane of a $13 video capture device that is getting this thing read in and displaying it on my screen right now. So, all right, not bad. Again, as I mentioned last time, this is, you know, about as good as I remember things when I was a kid, if not better, even with all the vertical noise bars and stuff in the video. That's not bad. So white looks good. And here's what white looks like on the scope. Let's go back to green. As you can see, these vertical lines. Well, I'm not sure yet where this is coming from, but of course, with these jail bars being vertical like this, it means that one horizontal scan time is doing something wonky in here. Well, it's not immediately obvious, but it's also not really the end of the world. I mean, this is... So let's go back to mode 1A. What's mode 2? I don't remember what that one was. Oops, it helps if I type it into the right window. Mode 2 is actually, of course, graphics mode 2. And that little mode 2 program, all it does is it puts it into mode 2, but it doesn't initialize any of the DRAM. So what I'm looking at here are just random bit values that obviously create and set the color values of various pixels coming out of the chip. Almost looks like a woven tapestry of some kind. But it's fairly stable, as again you see some of these saturated colors next to each other causing a little bit of quiver in there. The rest of it's okay. That's, again, very common with composite video. I'm going to call this a success. Oh, another close-up shot of the color burst while we're looking at this multicolored screen display, and it looks pretty good. It could be better. And you can see some switching noise maybe in there from, you know, the digital circuits and stuff. I think we can improve the overall filtering on the power. But I think we are in the mode, the ballpark where we might be able to play some kind of video games or something like that. So chime in on the YouTube comments or the Discord. And let me know what you think here. So at this point, that leaves us with these input buffers. And the joystick ports here really is all about that's left. So I dug up an old 138 and a pair of 244s and put them in here. Now, if you remember when I was testing the Rev Zero, I used Sim4LS HC 244 chips because that's what I had lying around. I had to dig a while to find these, and they got an 82 date code, so they've been around the basement for a while. The benefit of using the LS244 versus the HCT is that the way the input circuitry works on an LS chip is different. And I mean, that's basically the kind of things that happen. That's why they have different series of chips, depending on what you want them to do. These are genuine TTL chips, which means if you don't connect up these pull-up resistors, which, like I said last time, I don't have a lot in stock, they're kind of expensive, and I don't want to waste them if the board's not going to fly. So it would be nice to be able to test it without them. Now, genuine TTL chips tend, not always, but they tend to look like binary ones if they're left floating, which is exactly what we want. Okay? It's not reliable, but it probably is okay for a simple joystick test if we just hook up the DB9 and stick it in here. Now, again, these are not things I have a lot of in stock, and they're, more expensive than a lot of other things, even the SIPs, right? So I don't want to waste these if the board doesn't work. So I'm going to just stick it in there. I did this last time. I kind of like bend it a little bit to make these the pins come into contact with the 9-pin holes down there, and I should be able to see this thing work. Start with the smoke test. So far, so good. The LEDs are flashing like they should. This is probably okay. Temperature check, right? That's always a good sign. Okay, now, what do we need to do? I don't have a program that I've saved in here that tests the joystick yet. So let's go ahead and write a quick one. As you recall, what I want to do is I want to read from port, time to open the schematic. I don't remember what port it's on. Okay, as you recall, I put the, one of these, the A8. These are the port names that are associated with the latch enable here. So this port A9 and port A8 for these two latches. So if I just simply write in A9, in A8, and then say jump. Remember, we're dealing with 8080 opcodes here, not Z80, because I'm running DDT. Back to 100. Oopsie. It would help if I... How many times have I done this? A9 in A8. Jump back to 100. There's our super awesome test program. Just run this in a spin loop. And what I believe is going to happen is that we'll see FFs on both of these ports. So let's just trace like 1,000 or something like that. Perfect. So here's the fire button. You can see it chattering back and forth between FF and FE. Up, left, down, right, and of course it stops. Well, we'll just start it up again. Actually, this is kind of hard to read because it's going back and forth. So let's edit this advanced program that we have and just rewrite it in, what are we looking at? A9, jump to 100, and run it again. So there's the fire button, FE, left, FB, BF, DF, 7F. So this is the joystick going up and around and on the 4 angles. That looks like it's working perfectly. Let's try the other port. Move over the DB9, bend it a little bit to make contact. Fire button, left, down, right, up, in the four corners, looking good. All right, joystick works. The clock on the wall says that this video is getting too long, so I'm going to go ahead and install the diode here that's in the interrupt request signal over here. We're going to leave the interrupts for another time. They're not as straightforward, obvious, and simple as they could be, because this thing is probably going to need us to run the Z80 in mode 1, while the retro board, because it has a CTC here and an SIO, wants to run in mode 2, so we've got to resolve that in some way. All the while, by the way, when we're playing around with like mode 0 and mode 1, the use of debuggers like DDT can get very confused because they use the restart instruction and the restart vectors, as does the mode 0 and mode 1 interrupts. And so that might take a little thinking, okay? So we'll leave that for another time. All right, so I think this is going to be a success. I'm going to put the diode in, like I said, and call it a day. At some point down the road, we'll get more into the details on the interrupts. I think we got to go in the Rev 1 board here. Thanks for watching. See you next time.